Hello class. This video is going to be some general algebra notes. As noted, I have a couple of different videos that are organized by topic. That way, if there's a particular topic you need to come back to and you need to scroll through the video to rewatch, it's chunked into those convenient topics. So instead of doing one long video, there's a couple of shorter videos. This is the one that's on just general algebra notes. And I want to scroll through and show you some of the things that we're going to be talking about, and then I'll get started. Again, I'm not going to read to you, but what I am going to do is show you where some of these notes are, go over some key concepts, and then we'll get started. So here, this is some general notes that's going to help you be successful because these concepts come up in several different assignments. So the first thing you can see here is equivalent fractions, and there's some vocabulary. So I mentioned in one of my other videos about building your math fluency, because it's not always about just knowing the right answer. It's really about you having some skills that you can transfer to your career and life in general. And so we're building some foundational knowledge and that fluency through the vocabulary, which means you'll be able to speak the language of math because it is truly a language. So I'll scroll down here. Simplifying fractions, that's something that comes up often in many different assignments. It might not even be like the whole overarching goal is for you to simplify a fraction. You may be solving something else and having to simplify a fraction within that solve. And so I wanted to make sure that I go over that with you and what the words mean, because I think sometimes we hop into math and just try to do the problems, but we don't necessarily give time for ourselves to understand the math vocabulary. And as you know, part of watching the videos every week and doing the assignment is answering questions, and the questions for the assignment are verbal. So when you go in to take the little quiz that says I've watched these videos, you're also answering some questions, and the way you get the answers to those questions is by watching the videos. And so here's a great place for me to give you a question that will be on your lecture assignment. And that is a strategy for vocabulary in math. So I'm obviously giving you these Word documents and these videos that go over the vocabulary to help you build that math fluency. But here's a strategy. Consider printing this out and cutting strips of paper, or maybe enlarging it and making it bigger and cutting it out, or even rewriting on note cards, because that strategy of note cards is a really great memory strategy, and it does help you build fluency. And what fluency does in the class and as a practical matter is it helps you to not get caught up and frustrated by the words that are being used, and not be able to solve a problem because in math there's so many multi-steps that you have to follow. So you're following multiple steps and you're knowing the vocabulary, and if you get caught up on one thing, it might make it frustrating for you. So I think practicing the vocabulary and using note cards is a good strategy for that. So whether you use traditional note cards or you just print out the papers and cut them up and then just kind of test yourself is a good strategy. Also, psychologists will tell you that studying in short bursts over a period of time is better than having one huge long study session. And so if you study for 10 to 15 minutes at a time, like say you're riding in a car, not driving obviously, but that wouldn't be safe. But if you're riding in a car as a passenger, maybe you pull out your flashcards or your sheets of paper and you do a little bit of study for 5, 10, 15 minutes. It's going to help you in the long term more than just sitting down and trying to find one big, huge block of time to study. So psychologically or cognitively, it's a better strategy to do shorter amount of minutes, but also many of you probably struggle to find those big blocks of time in your schedule. So adding and subtracting fractions is also included in this video. And then exponent basics, writing expressions using exponents, distributive property basics. There's some examples there, and basics of solving equations are here in this video. And so that's a nice little smattering of topics here that you're going to come across frequently throughout your different questions that you're doing. So again, it's equivalent fractions, simplifying fractions, adding and subtracting fractions, exponent basics, writing expressions using exponents, distributive property basics, basics of solving systems of equation, and that's it. All right. I say that's it like that wasn't a lot, right? So let's get started. All right. So you've got your equivalent fractions vocabulary. So you've got the vocabulary fractions. So what is a fraction, right? Again, I don't want to read to you, but I want to attend you to bring your attention to these different vocabulary words. So what is a fraction? Have you ever really thought if you had to say the definition what it would be? A fraction is, I know you probably could think of what it looks like visually, right? But if you had to say the words in a math sentence, how would you say it? Well, you would say a number that shows part of a whole. So that's the lens I want you to look at this, these lecture notes through. And again, I will post this document for you. And then if you have equivalent or equivalent fractions, what does equivalent mean? It means the same value. Most of you probably know that. So if you have to make equivalent fractions, here's your steps you're going to follow, okay? So I wanted to break it down step by step because I'm a very concrete thinker, and I felt like if you had the steps, you could just go 1 and then 2, or even pause the video. You may even want to see some different examples. I mentioned Khan Academy in one of the other videos, and because that's a great online resource, you could, for example, put Khan Academy and then equivalent fractions into your Google search, and then that would bring up the Khan Academy video. So here are the steps you're going to follow to make equivalent fractions. You're multiplying or dividing the top numerator and the denominator by the same number. The fraction will look different, but it means the same. And here's some examples. I'll give you a minute to look at that. And if you need more than a minute, you can just pause the video. That's another strategy about pausing the video, right? Is you get to control the pace. And that's a beautiful thing both about these videos, the ones that are within your ALEKS textbook and Khan Academy, is that you get to pause the video and set your own pace for learning or rewind. So that's another strategy that hint might be on your quiz assessment for the lecture video assignment this week, is pausing the video. Simple strategy, but maybe sometimes people overlook that, right? All right, so there's some examples. So you'll notice in both of these, you're multiplying the top and the bottom by 2. So you're simplifying, which means you're making the fraction as small as possible. And then if it asks you about the greatest common factor, that's the biggest number that divides into both the numerator and the denominator. So numerator, denominator, and what's the biggest number that can go into it evenly? That's your greatest common factor. And here's your steps to finding the greatest common factor with some examples. So I'll leave the steps there and the examples for you. Again, you can pause the video if you need to. And also, again, look at 9 divided by 12. So that's an example, right? So what's the greatest common factor? So the greatest common factor for 9, the biggest number that can go into it, is 3, right? Because you can't divide 9 by anything else bigger than 3. And then for 12, it's 4, because you can't divide 12 by anything else bigger than 4. Nothing else bigger goes into 12. If you tried to go to 5 as an example, what's 12 divided by 5? It doesn't give you an even answer. So that's really, it's pretty plain and straightforward as far as in the steps for greatest common factor. Again, a lot of these math problems combine multiple concepts together, so that's why it's really important to build that math fluency. So what if you were adding and subtracting fractions and you needed a common denominator? Common denominator means it's the same bottom number in both fractions. And here are your steps for that with some examples again. I want to encourage you again, if you need to stop and pause the video or rewind, please feel free to do that. And again, this is your adding and subtracting fractions steps. So kind of going back to what we just said, right? Denominators need to be the same. You're adding or subtracting the numerators, which is your top numbers. And your denominator is the same. And then you're going to simplify. And remember up here, we talked about simplifying fractions. So there's your steps to simplify. And remember I said sometimes multiple concepts are matched together. So you may have to add and subtract or subtract and then go back and simplify as denoted here on step 4. So let's just look at it in an example. So if we have 1/4 and we're adding 2/4, what are we going to do? Well, the first thing we want to do is make sure the denominators are the same, and then you're going to follow your steps. So I'm going to mentally let you follow those steps as we look at these two examples. These are pretty easy, but the reason they're easy is so you can get the steps down. So in the first one, 2 and 1 can be added together because the 4 is already the same, so your denominator is already the same. So you're just adding because it says to add. How do you know to add? Because it says to add the plus sign. You keep your denominator the same, and then you're going to simplify, which in this case you cannot simplify. 3/4 is already simplified. You'll see in the second one, it's pretty much following the same steps except it's subtraction, and we do need to simplify because 2/8 can be simplified to 1/4. All right, now what happens when we complicate it a little bit and we have exponents? Well, what are exponents? Well, there's actually two parts. So you have your base, which is your number that's being multiplied. So down here in the example where it says 2 to the 3rd power, 2 is your base and 3 is the exponent. So what is your exponent? How many times the base is being multiplied by itself. Not by the number of the exponent, but by itself. So what does that mean? 2 multiplied how many times by itself? That means 2 3 times. So 2 times 2 times 2 is 8. 5 2 times. 5 times 5. Okay. Writing expressions using exponents. So you're really kind of doing this the opposite way. You're taking this, say, 2 2 2, and collapsing it back into 2 to the 3rd power. So if you would imagine 2 2 2, how would you collapse it? It would go back to the left. So you're just reversing it, right? So this is the reverse of the first step. And then I'll just use this second example here, 3 times 3 times 3. That means 3 times 3, 3 times, right? 3 times itself 3 times, so 3 to the 3rd power. All right, distributing these. So when you have the distributed property, this is the basics. This is something you'll practice in your assignments. You're basically giving out to each term what's inside the parentheses. So let's first look at the steps, and then we'll look at some examples you see here. So first you're going to multiply the number outside of the parentheses by each number. You see each is capitalized. And then you're just going to add and subtract. So let's look. The number outside and then add and subtract. So you're outside by each, right? So here, multiplying it by each number. So that means 2 times 3, 2 times 4, okay? So the 2 and the 3 are matched together, and then 2 times the 4 because they're inside of the parentheses. And the one below it, 3 times x, so x can be multiplied just like a number, and 3 times 5, okay? So what is 3 times 2? It's 6. What is 2 times 4? 8. So there you have your 6 and your 8 here. We started with a plus number here, and so you're just adding those right there. 3x plus 3 times 5 is 15, so you've got 3x plus 15, and here you're not going to be able to get to a number. The answer is the final answer is 3x plus 15. Remember I told you it's not always an answer, it's a solution, right? It's the solution to what they're asking you to do, which is distributing those properties. And so sometimes your answer is not a number. Do not drive yourself crazy always thinking you have to come up with a number. We don't know what x is. We have no way to solve for x. We just know that 3x, 3 times x, right, plus 15 is the solution in this case. So speaking of solving systems, here's your vocabulary. So again, we're really talking about math sentences here, where you have systems of equations or 2 or more equations within the same variables, and a solution, which basically is a value that makes both equations true in this case. So there's a couple of different methods. There's the substitution method, and I'll give you a chance again to read this and look at the examples. You can pause this video and read through this, and then practice with your examples. Give you a minute to decide if you want to read or pause. So here you're going to solve one equation for the variable, and then you're going to plug that into the other one, okay? So it's a lot of steps, but it's really honestly pretty straightforward. And once you solve for one variable or letter, then you're going to plug it into the equation and solve for the second variable. So let's just look and see what that looks like. All right, so you might want to, and this is a great place to have your math notebook, right? We talked about printing out the notes. And so you have solving one equation. If you have that in front of you, you know this is your equation 1. So step 1, you're going to plug x equals 3 into the equation that's up at the top. So if x equals 3, here, equation 2, you're going to plug that into where it says x, because we know that x is 3, and then you're going to solve. And then we're going to come back and look at the y. Once you follow those steps, you'll see that you have x equals 3, right? We started with that. But then we solved 3 plus y equals 5, which means we moved the 3 to the other side. We solved with the math, and we ended up with 5 minus 3, which is 2. Alrighty, so what was the strategies we talked about in this video? We talked about printing or making flashcards, right? We talked about that. And then we talked about our videos. And there was one more. Let me go back. Oh, we talked about practicing, making sure you don't have, don't try to make yourself like long study sessions, okay? All right, well, I'm going to save this, and then we'll get on to our next video.